Assalamu alaikum and good evening, everyone. Today we are going to start February-March 2024, paper 2-2. Okay. So let's start with question number 1. Bismuth is an element in group 15 of the periodic table. Bismuth has a metallic bonding. Draw a label diagram to show the metallic bonding in bismuth. So see, as they have mentioned you that it has a metallic bonding. So for a metallic bonding, it's very easy. You can draw the structure as you draw it in your O levels, that you need to draw the same size of cations. Like this. And then to show them a cation, you are going to put a positive charge in the center of the nucleus like this. So in this way, you will show the layers, and between the layers, you are going to put the negative charges, which are the free moving or the delocalized electrons, which are present between the spaces in the lattice of the metal. Is this understandable to you guys? Yes, Fatma, 1 minute. I'll explain it later in the class. Okay. Now B part. Bismuth reduces water to form bismuth oxide, a colorless gas that ignites with the squeaky pop. With a squeaky pop also forms. Okay. So squeaky pop means that a hydrogen gas. Okay. So the equation would be water plus bismuth to form bismuth oxide, and they have given me the formula Bi2O3, and then hydrogen gas. So to balance the equation, there are 3 oxygen over here. So I'm going to put a 3 over here, and I will put a 3 over here to balance the hydrogens. And then there are 2 bismuth over here. So I'm going to put a 2 over here. Now the equation is balanced. Is this clear to all of you? Okay. Now part 2. Bismuth is a yellow insoluble solid that melts at 190 Kelvin. So if it's a 190 Kelvin, it means that it is a very high temperature, right? The molten compound conducts electricity. See, the molten compound is conducting electricity. It means they are, it's an ionic one, right? Very good, Umar. Reduce the structure and bonding of Bi2O3. Explain your answer. So yeah, very good. It has a very good Vanin. It has a giant ionic lattice, and there are strong covalent bonds. Yes, Fatma, I'll explain at the end of the class, okay? Between ions. Okay. Hence, high amount of energy is needed, and in molten, ions are free to move. That's why it conducts electricity, right? Now, C part. Bi2O3 bismuth oxide can use to form sodium bismuth as shown in equation 1. Okay. Reduce the oxidation number of bismuth in Bi2O3 and NaBiO3. So it's easy. See, the net charge is over here 0, and we know oxygen has a -2 charge, and there are 3 oxygen, which makes it -6. So it means that the net charge is 0. So the 2 bismuth atoms ions has a charge of +6, the oxidation number. So there are 2. It means one has a +3 oxidation number. So I'm going to write over here +3. And over here, if you see, again, the oxidation number is 0 over here. It's -2 times 3 makes it -6 and +1. So C +1 -6 is equals to 0. So in the middle, it must be +5. Yes, very good, Hassan. So I'm going to write +5 over here. Okay. Now what they are saying, identify the reducing agent in equation 1. So the reducing agent is the one which undergo oxidation. So the one which undergo oxidation, its oxidation number increases. So if you see that Bi2O3, in Bi2O3, bismuth has a +3, and when it turns into product, it has a +5. So it means it undergoes oxidation. So bismuth oxide is a reducing agent, because it oxidizes itself and let the other substance to get reduced. Is this clear to all of you? Okay. Now part D. NaBiO3 is an oxidizing agent with the similar properties of KMnO4. Okay. So if you recall the KMnO4, it oxidizes alkene, alcohols, and primary and secondary only, aldehyde. And beside these, as I have told you, in carboxylic acid, it's just methanoic acid and ethane dioic acid. These are the 2 carboxylic acid which can be oxidized. Figure 1.1 shows an example of the use of NaBiO3 as an oxidizing agent. Okay. Explain the term oxidizing agent. So, okay, they have asked you to explain it. A substance which oxidizes another substance by gaining electron itself. Yes, another molecule and letting other species to lose electron. So when the other species lose electron, it is being oxidized. And this is the one which caused the other species to lose electron. So that's why it's an oxidizing agent. Now, part two. Compound X forms when methyl 2-butene reacts with KMnO4. State the essential conditions for this reaction. Okay. This is the compound X. And they are saying it is formed from methyl to methyl butene. So it means that if I go back towards alkene, it could be like this only. Yes, very good, Umar, very good, Bani. So, and we are getting diol. So it means that diol is actually, for diol, we need cold. Yes, very good, Fatma. Dilute, acidified, potassium magnate. Okay, now complete table 1.1 to show what is observed when compounds Y and Z react separately with the named reagents. Okay, Banin, one more thing, when we are using cold dilute and then you are saying heat under reflex, so these two are completely different conditions, okay? Because on heating doesn't keep it cold, so we have to keep it cold specifically to make the diol. Okay, so complete table 1.1 is what is observed when compound Y and Z react separately with the named reagents. Okay, compound Y, no reaction with sodium carbonate. So if you recall, with sodium carbonate, only acid reacts, right? Now, if we look at Z, Z is an aldehyde, right? And Y is a ketone. So obviously, if Z is an aldehyde, so again, we are going to observe no reaction over here. Aqueous alkaline iodine. Yes, see, Fatma, you were asking about this test. So remember, this test is positive only when a sample has either CH3C double bond O group or you can say and, yeah, or would be fine, and CH3C OH and H group. If these two specific structures are present in the compound, then the aqueous alkaline, uh, gives the positive test. So this is the case for aldehyde and ketone. If there is an aldehyde or ketone, and that aldehyde in that aldehyde and in ketone, that if carbon double bond O have a bonded to CH3, then they are going to give you this iodoform test positive. Or if in alcohol, we have this group CH3CHOH, and here this bond, it can be a carbon chain, it can be a alkyl chain, okay, or hydrogen, it doesn't matter. But the carbon, that is the important thing, that the carbon which has a OH group is bonded to H and CH3, then that kind of an alcohol gives you a positive, uh, iodoform test. And if we have C double bond O bonded to CH3, that is an aldehyde or ketone, then it gives you a positive aqueous alkaline test. Okay, just give me 2 minutes, please, everyone. Okay, am I audible to all of you? Yes. So, and for an alcohol, this structure must be there. Is this understandable to all of you? Yes, Fatma, did you understand? So, in this case, the observation would be yellow precipitate if the compound has this structure. Yes, very good, Hassan. Yes, if anyone of you has any confusion, please ask. So now look over here. If you see this ketone, isn't it a CH3 bonded to C double bond O, and the other side it's CH3. So we are getting this thing. So it means it can show you a yellow precipitates. So this test would be positive, the iodoform test. And then C double bond O bonded to a CH3 in compound Z, right? So see, we have this same group over here as well, that our CH3 has a one side C double bond O. So it means both are going to give us a positive test for aqueous alkaline iodine or positive iodoform test. And it means that we are going to observe a yellow precipitate with compound Y and yellow precipitate with compound Z as well. So that is the iodoform test. Okay. Now, construct an equation for the reaction of Z with NaBH4. So if you recall, NaBH4 is a reducing agent and is a reducing agent which reduces aldehyde and ketone. So the atomic hydrogen is used to represent an atom of hydrogen from the reducing agent. Okay. So compound Z, if we see Z, Z is an aldehyde CH3, C double bond OH. So I'm going to write Z as a CH3CHO. then I'm going to write atomic hydrogen. And we know aldehyde turns into an alcohol. So when it turns into an alcohol, it will form CH3, CH2OH. So two hydrogens are being added. So I'm going to put a 2 over here. So if you see the displayed formula, I'm not going to make any hydrogens. See, this was the structure. And on oxidation, on reduction, the whole thing remains same, that oxygen, carbon oxygen double bond turns into a single bond, and then all of the sides we get a hydrogen. Yes, all the aldehydes becomes primary alcohol on reducing. Okay, now E part. NaBiO3 can be used to determine the concentration of manganese. The ionic equation for this reaction is shown in equation 2. Okay. The student uses the following procedure in the experiment. Add 100 centimeter cube of a saturated solution of manganese to a volumetric flask. Okay. Volumetric flask is like this. You guys have seen in the labs. Okay. So what they are saying, that there is a 100 centimeter cube, this volumetric flask. No, in this volumetric flask, 100 centimeter cube aqueous manganese to positive solution has been added. Add distilled water to make a 1 decimeter cube diluted solution. So it means that the total of this solution, this flask capacity is 1 decimeter cube, and we have added the distilled water in it. So we got from this, it means we got from this diluted Mn aqueous solution having a volume of 1000 centimeter cube or 1 dm cube. Is this understandable to all of you, this outline or this method? Oh, okay, sorry. Thank you. Thank you, Hasan. Sorry, I forgot. 2,4-DNPH. If you recall 2,4-DNPH, it's for carbonyl only, whether aldehyde or ketone. Either it's an aldehyde or ketone, both can give this test positive, and we see that Y is ketone and Z is aldehyde. So, and here with the 2,4-DNPH, we always get orange PPT. Then tolerance reagent. Tolerance reagent is always ketone gives a negative test and aldehyde gives a positive test. So in ketone, we are going to mention no reaction. And yes, very good, Bunny. Silver mirror for Z, which is aldehyde. Till here, is this clear to all of you? Okay. So in this, if you recall again, we have initially 100 centimeter cube of a magnate, aqueous magnate solution, which we have put it in a 1 decimeter cube solution or volumetric flask. Then we add water in it, and as a result, we get a diluted solution of a magnate whose volume is a 1 decimeter cube. Till here, is this clear? Now see, next thing. Titrate 25 centimeter cube sample of the diluted solution with 0.1 mole per dm cube of NaBO4. So see, this is where you students ignore the thing. See what they are saying, that from this, we have taken out 25 centimeter cube manganate and titrated it with 0.100 mole per dm cube NaBiO3. Till here, is this clear to all of you? Now what they are saying, 25 centimeter cube sample of a diluted aqueous manganate reacts completely with exactly 21 centimeter cube. So see, we have this volume of manganate, the diluted solution, which is taken out from 1 decimeter cube of a manganate, which is made by mixing the 100 centimeter cube with the rest of the distilled water. And this NaBiO3, its volume is 21.50 centimeter cube. So we got the volume and we got the concentration. Calculate the concentration in mole per dm cube of Mn2 positive in the saturated solution. Okay, now see how you will attempt this question. The first thing that you need to do, you have to find the moles of NaBiO3. Why we are going to find the moles of NaBiO3? Because we have its volume and concentration. So the moles of NaBiO3 is equals to its concentration times its volume, and that volume, you know, in this formula is always in decimeter cube. So if I put the values, the concentration is 0.100, the volume is 21.50 centimeter cube. So I have divided with the 1000 to turn into a decimeter cube. Now can anyone calculate? Okay, Dua, it's 2.15 exponent minus 3. Okay, so 2.15 exponent minus 3 moles, right? Now we got the moles of this thing, and now we have to find the concentration of this, right? And they are asking the concentration in the saturated solution, which was this. So first what I'll do, I'll find with the help of a mole ratio, I will find the concentration I find the moles in this 25 centimeter cube. So we will make the ratio BiO3 negative or NaBiO3 is to Mn2 positive, and the ratio is 5:2. So the moles of BiO3 is 2.15 exponent minus 3. Then the moles of manganate would be X. Calculate the value of X. X is equals to 2.15 exponent minus 3 times 2 divided by 5. Can anyone calculate it and tell me the answer, please? Okay. Thank you, Bani. We are getting 8.6 exponent minus 3 moles of manganate. But in which volume these moles are? If you see, we have reacted 25 centimeter cube. So these are the moles in 25 centimeter cube. And we know we take out this 25 centimeter cube from the 1000 centimeter cube. So in 25 centimeter cube, we have 8. Okay, it's exponent minus 4 moles. So in 1000 centimeter cube. Now if you see, whether you use the term 1000 centimeter cube or you use the term 100 centimeter cube, because if you see, if you read this statement and this statement, you are able to know that the actual moles comes from the 100 centimeter cube, and then we have diluted it to the 1000 centimeter cube. So whatever the moles I have found, I will find in 1000 centimeter cube are actually the moles which comes from the 100 centimeter cube of the saturated solution of manganate ions. Is this understandable to all of you? So is to X. So if I calculate the value of X, it is going to be 8.6 exponent minus 4 times 1000 divided by 25. Can anyone calculate it and tell me the answer, please? Three significant figures, please, Anshara. It's going to be 3.44 exponent minus 2. So these are the moles in diluted 1000 centimeter cube or concentrated 100 centimeter cube, because the centimeter cube or 1 dm cube is being prepared from the 100 centimeter cube. So we got the volume, we got the moles. Now we will put in the formula of the concentration, that 3.44 exponent minus 2 moles divided by 100 over 1000 to turn it into a dm cube. Now you will calculate, you will get the answer. So it's going to be 0.1, and 0.1 when moves upward, it's exponent. So it is going to be, if I'm not wrong, 3.44 exponent minus 3. Isn't it? Okay. So we are getting 0.344, right? Okay. Now question number 2. Chlorine Cl2 reacts with many elements and compounds to form chloride. Table 2.1 shows information about some chlorides of period 3 elements. Okay. Complete table 2.1. Formula for chloride we know: with the sodium, it's NaCl. With magnesium, it's MgCl2. With silicon, as it's in group 4, it's SiCl4. Its structure is giant. Magnesium chloride is giant ionic as well. And silicon chloride is simple. Over here, the bonding is ionic. Over here, the bonding is ionic. Here, they have mentioned you the bonding that it's covalent. Okay. Sodium chloride, if you recall, we have studied so many times. It's neutral. It's 7. Okay. Can anyone please confirm me? Someone is telling me that the answer is 0.0344, 3.44 exponent minus 2 divided by 0.1. I think I should solve on my own. 0.0344 divided by 0.1. Yeah, it's 0.344. Yeah, it's 0.344. 0.344 is correct, Dua. Okay. So it's 7. Magnesium chloride is 6.2, but silicon chloride is a highly acidic, because when you dissolve it in water, you will get the silicon oxide, which is an acidic, and HCl in aqueous. So its pH is going to be around 2. Okay. Now, group 7 questions from the group 7 halogens. When chlorine reacts with cold sodium hydroxide, chlorine is both oxidized and reduced. If you recall, this one is called, this type of a redox is called disproportionation reaction, right? The products are sodium chloride and G. If you recall, you have to remember this, that G is NaClO. State the type of redox reaction in which same species both oxidize and reduce. See, so we have already discussed. It's a disproportionation reaction. Identify G. So we have already identified it. It's NaClO. Write an equation for the reaction of chlorine with hot NaOH. So if you recall, with hot NaOH, the products are different. One product is different. Chlorine reacts with, when hot concentrated sodium hydroxide, we will get sodium chloride. Beside this, now instead of NaClO, we get NaClO3 and H2O. Now, if you need to balance the equation, there are 3 moles and there are 6 moles. Here we got 5, and over here we got 3 moles of water. So you need to remember these equations. Okay. Now, part 4. Describe fully What is observed when silver nitrate is added to aqueous solution of a chloride of sodium followed by dilute sodium hydroxide? So if you know that they ask you observed, so it means what will you see when you add sodium chloride, when you add silver nitrate? So yeah, very good, Anshara. White precipitates are formed first. Very good, Hassan. On adding aqueous silver nitrate, white precipitates are formed. Then adding, yes, very good, Banin, very good, Fatma. Then adding aqueous ammonia gives clear solution as white precipitate dissolves. Is this understandable to all of you? Now, C part. An excess of chlorine reacts with the phosphorus to form PCl5. PCl5 is a simple molecule in a gas phase. It also exists in a solid as two ions PCl4 negative and PCl6 negative. Complete the table 2.2 to identify the shapes of each of these species. Okay, so if you recall PCl5, phosphorus is in group 5, right? Its group is 15 or 5. So it has a 5 valence electron and here it's PCl5. So there are 5 bonding pairs and no lone pair. So in this case, the shape is trigonal bipyramidal. Whenever we have this kind of a molecule where uh, there are 5 bond pairs and no lone pair, then it's trigonal bipyramidal. Okay, here they have mentioned that it's tetrahedral. Okay, now PCl6 negative. So see, with chlorine 6, with phosphorus 6, chlorines are bonded. So in that case, yes, very good, Banin. When there are 6 bonds, it is always octahedral. Okay. PCl5 reacts with J to form phosphoric acid. Identify J. Okay. State the type of a reaction. So if you recall that phosphoric acid when reacts with J, so J is water because when we no, sorry, it's PCl5. PCl5 when dissolves in water, we get H3PO4 and HCl. So if you have to balance the equation, you have to put a 5 over here. 5 plus 3 makes 8 hydrogen. So I'm going to put 4 over here, 4 oxygen and 1 phosphorus. And so see, so it means J is water. So when an ionic compound reacts in water, which reaction is called? Yes, very good, Hassan, very good. Anshara, that the type of reaction is, yes, very good, Hassan, it's hydrolysis. Okay. Now, D part. Chlorine reacts readily with propene to form K, 1, 2 dichloropropane. K can be used to form L. Okay. So if you see chlorine, so it's an electrophilic addition. And here isn't its elimination. Okay, this reaction, for this reaction, there is no conditions required. It occurs at RTP. And here the elimination, we required sodium hydroxide in ethanol. Aqueous sodium hydroxide gives the substitution. Because if you see this chlorine from here and a hydrogen from here gets released and the double bond has been formed. Okay, now complete figure 2.1 to show the mechanism for the reaction of chlorine with propene. It means they are talking about this reaction, electrophilic addition, right? Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. Okay. So if you recall that I have told you that when the halogen molecules comes closer to the double bond, the dipole is induced. Yes, not for all elimination from alkyl halide. Whenever we need to, when we have to do the elimination, ethanolic sodium hydroxide is used. And from alcohol, when we need to do this, either aluminum oxide or phosphoric acid has been used. Okay, so the curly arrow from the double bond over here and this over here. As a result, the second chlorine, which is at the bottom, turned to be chloride ion and get separated. Is this clear? Now, if you see over here, there are two carbons. The carbon on the left has a 2 hydrogen and the carbon on the right has a 1 hydrogen and 1 CH3. So it means that this is going to become a positively charged carbocation because this is going to form a secondary carbocation. And in the mechanism, we always make the carbon cation, which is more stable. And the left one has a 2 hydrogen. So it means it is going to make a primary carbocation. So instead of that, I'll put the chlorine over here. This chlorine gets bonded over here. And the other carbon, which can form a more stable carbocation, becomes a carbocation. Is this clear to all of you? Now, from this lone pair, there is another curly arrow towards this positively charged chlorine, and as a result, you see this bond has been made. Is this clear to all of you? So see, for this thing, there are 4 marks. Okay, now part 2, identify the reagent and conditions for reaction 2. So we have identified that the sodium hydroxide and ethanolic conditions and heating as well. Sodium hydroxide in ethanol and heat. Okay, draw one repeat unit of the addition polymer that forms from L. So where is L? That is L. Okay, so if you see the compound L is this, and they are asking to draw one repeat unit. Okay, so there are 2 carbons. Between them, there is a double bond. The carbon on the right has 2 hydrogens, and the carbon on the left has 1 CH3 and 1 chlorine. So what I'll do, I'll put a single bond and then make the empty bonds on either side to show one repeat unit. Is this clear to all of you? Okay, so here we are done with the half of the paper and we are left with the next half that we are going to do in our next class. Okay. And one more thing, as the day after tomorrow, yes, Dua, it is because C, there is a C and there is one line, which means there is a 1 carbon over here. And if this carbon has a 1 bond with the carbon, so it means there are 3 hydrogen. So that is the basic knowledge of like skeletal formula. Okay. So we will be doing the next part in our next class.